In this particular video, we're going to have a discussion on AS physics, and we're going to have this video here based on the kind of request that was made by Yaya Ahmed. Yaya Ahmed says that he's going to do AS physics, and now we would like to understand what really the topic is going, what the concept that, what the topics are going to be in AS physics. Is that this all in this chapter, you need to understand different basic derived quantities which can only be measured. So my pen is really giving me trouble. Which are the quantities which can only be measured? So there's no another way you can be able to get them other than actually measuring them. So what are the quantities which you can measure? You can be able to measure length, you can be able to measure mass, you can be able to measure time. Those are some of the quantities, the basic quantities that we are talking about. So we need also to mention that these physical quantities, physical quantity unit, so which means that you will only say 5 kilogram. Now this is a basic this is a physical quantity because it has the value, the magnitude, and also we have this is the numerical, which is telling you the quantity, and also we have here the unit of measurement. In AS physics, which is 9702, you need to learn about 5 basic physical quantities, and then we shall talk about derived quantities. Derived quantities. Derived quantities are obtained from basic quantities. In that case, for instance, if we are talking about pressure, we know pressure is force over area. So which means that pressure is obtained from mass times acceleration over area, which is maybe length times width. So which means that all this we can be able, because area can be obtained from length. So which means that derived quantities are going to be obtained from basic quantities. So for AS physics, what you need to remember is the 5 basic quantities that we are having here, and then I'm going now to take you through how to determine the SI base units. Yeah, so the next once you've understood what are SI base units, the next part we're going to look at is to determine the base SI unit of different derived quantities. Now in this case, for instance, we are told pressure. So the first thing that you need to remember is that pressure is equals to force over area. Now once you've understood that pressure is equals to force and area, you need to understand also that force is a derived quantity which is going to be obtained from mass times acceleration. So we can be able to say pressure is also given as force over area, but force is mass times acceleration over area. So once you've identified this, the next part we're going to do is to write, because acceleration we know is obtained from what? It's obtained from change in velocity over time. So which we can say that the unit for mass is kg. We multiply to acceleration unit is meters per second squared then I'm going to divide this by the unit of area, which is meter square. So at this point, what I need to do is to simplify whatever I'm having here, and I can decide to multiply all through. If I multiply by s squared, and also here I multiply by s squared, it means that I'm going to reduce this equation to that, and then we shall have now our equation becoming what? Kilogram times meters, which is divided by meter square times s squared. So at this given point, you can see here we have 2m, then it will cancel with one of the m that we're having, so we remain with 1m down here. And by the way, at the end of the day, we are going to have this equation reducing to kg per meter -1, because we are having over this, and second squared, like that. Now whatever we have is the base SI unit of the derived quantity, which is pressure. But now let's look at also if you are given power. What is power? We know power is derived from, or is obtained from, work done divided by time. Yeah, divide by time. So which means you need to understand power is work over time. And how do we get work done? Work done is force times distance divided by time t, right? But we also have to remember that force is the product of mass and acceleration. Then we are going to reduce this equation to become mass times acceleration times distance over t. So this is now the quantities which are used to calculate power. And in this case, now we are going to write the units for mass. The unit for mass is kilogram, times the units for acceleration is meters per second square. Yeah. And then the unit for distance is meters, and all this that we are having here is divided by time, and the units for time is seconds. I like dealing with the fractions first, so I'll multiply by s squared here, I multiply by s squared here, so that I can be able to have all the rights reserved for me, for right to cancel this and this, so that my equation is going to reduce to kilogram meter square, because meter times meter becomes meter squared, divided by s cubed. So this is the part I have, and now I need to rewrite this equation, kg meter squared s cubed. So I need to write this equation, and I can write this equation as kg meter squared s -3. So basically that is the SI base unit for the quantity. So what you need to do is to make k the subject to the formula, and this is going to be power divided by surface area times temperature raised to power 4. So what we need to understand, already we have worked out, this is the rate at which this is the base unit of power. So which means we are going to use them at this given point, and then we can be able to say this is going to be equivalent to kilogram multiplied to meter squared multiplied to s -3. Already we have gotten the SI base unit for power. Then we can be able now to divide by surface area is meter square, and the units for temperature is Kelvin. So this is going to be Kelvin raised to power 4, because temperature is raised to power 4. Then now I can be able to cancel basically this part and this part, and then our final equation is going to be kg s negative 3 and k raised to power 4. So this becomes the basic base road is going to be traveling from one end to another. Yeah, so we shall be having the length of this metal rod to be L there, and then temperature will take some time T to travel from this end where we have temperature 1 and the other end we have temperature 2. So this is going to be L times E. So we're going to say our C is going to be equals to E L, so that we can rearrange this, and we have said that E is going to represent what? Second. Yeah, the time in second, the unit for time in second, because cross-section area, if we are having this, we have made C the subject of the formula, and that is going to be EL, which is energy times length, over cross-section area into temperature 1 minus temperature 2 cross the bracket T. So that we are going to substitute the units, because we have said force is equal, energy is equal to the rate of doing work. So we know work is force times distance. Then this is going to be force times distance. Then but force is mass times acceleration, because you have to remember that force is equal to mass times acceleration. And then the unit for mass is kilogram. The unit for acceleration is meter per second square, and the unit for distance now here is meters, and the unit for length is actually meters. And then the unit for area is meter square. The unit for temperature, even if it's subtracted, that remains the unit for temperature in that case, and that is going to be Kelvin. And the unit for time in this case is going to be seconds. So we shall have kilogram, meter times meter, it becomes meter squared. I've left 1 m so that I'll have meter squared cancelling out, because at the denominator also we have that. So that we are going to have this equation reducing to that, then we shall have s cubed. Our equation is going to be s cubed like that. We shall have kilogram meters, s negative 3, Kelvin negative 1. So basically that's what you're going to do. So the next particular tutorial, we are going to look at the next topic, which the student requested, and I need to say this is a request that was made by one of our subscriber who's going to do AS physics. And in that case I said I'll have to treat that quite urgent, so that you can be able to understand what you are supposed to do in AS physics. If you have found value from this particular video, I really need to say that you can really support ProfLearn by subscribing and also joining our Patreon page, where you can be able to access the PDF of this PDF I was working at this given point. So that you can be able to access this PDF of these particular areas that I've worked out. Guys, please just subscribe and also leave a comment down below, so that you can be able to, so that I can be able to know whether you got value from this particular video. Sometimes when we're doing IGCSE physics, you'll be expected to now, for you to get more of for you to get more of my tutorials, I want you to check in the description. I'll be adding a link that is going to take you straight to kinematics, dynamics, forces, density and pressure, work, energy, power, deformation of solids, waves, superposition, electricity, DC circuit, particle physics, and A-level required practicals, which I did. See you in the next tutorial, guys.